Good evening, dear students. Let's start collision. As I promise you during Google Meet, I will teach you collision and send you a video. When you play cricket, what you do, suppose you are batting, you hit a ball. When you hit a ball, you are applying a large force for a short period of time. There is interaction between bat and ball for a short period of time. In badminton, when we smash a shuttlecock, we smash cock for a small time interval. So these are collision. When in day-to-day life a car hits a bicycle, it is collision. How we define? It means collision is short time event in which two or more objects interact with each other and thereby affects subsequent motion. So this is collision. Now there are two types of collision: elastic collision and inelastic collision. How we differentiate elastic and inelastic collision? So in elastic collision, total energy, momentum and kinetic energy, if all are conserved, means momentum before collision and after collision is same. Kinetic energy before collision, after collision is same. It is elastic collision. And in inelastic collision, total energy and momentum, these two remains conserved, means total energy and momentum before collision and after collision is same, equal, but the kinetic energy does not conserved, conserved. Okay, after collision, either it convert into heat or in sound or in light. Let's discuss elastic collision in one dimension. We are going to discuss elastic collision in one dimension. Here you observe that these are the two bodies. Their masses m1 and m2. Their velocities are u1 and u2. Here u1 is greater than u2. Both the bodies are moving towards positive direction of x-axis. The bodies collide with each other. After collision, their velocities change and becomes v1 and v2. Then, as we know that this is elastic collision, so momentum will be conserved. Momentum of this body m1 u1. Momentum of second body m2 u2. So total momentum before collision is this. As momentum is conserved, that's why momentum after collision, it will also be conserved. So we get m1 v1 equal m2 v2. Now you bring the terms which is having mass m1. So when we transpose this term this side, we get m1 u1 minus m1 v1. We take m1 common. Okay, so inside the bracket we get u1 minus v1. And this term we bring towards right hand side. So transpose it towards right hand side, we take m2 common and we get v2 minus u2. Say equation number 1. Say this is equation number 1. Now you observe momentum is conserved as well as in elastic collision kinetic energy will be conserved. So kinetic energy of first body 1 by 2 m1 u1 square plus second body 1 by 2 m2 u2 square equal 1 by 2 m1 v1 square plus 1 by 2 m2 v2 square. Okay, kinetic energy before collision equal kinetic energy after collision. You see each term having 1 by 2. So we take 1 by 2 and 1 by 2 will be cancel out. Once again you do the same. This is m1 u1 square. This is m1 v1 square. Transpose this term towards left and take m1 common. You will get u1 square minus v1 square. Similarly, you transpose this term towards right hand side and take m2 common. You will get v2 square minus u2 square. Say this is equation number 2. And now we divide second equation from first equation. So we will get m1 u1 square minus v1 square upon m1 u1 minus v1. This is from first equation. This is m2 v2 minus u2 square upon m2 v2 minus u2. Here you see that m1 and m2 is cancelled. Here this is a square minus b square. You know that a square minus b square equal a plus b into a minus b. So a minus b will be cancelled and you will have u1 plus v1 equal v2 plus u2. Stop. So this is u1 plus v1 into u1 minus v1. Similarly here v2 plus u2 minus into v2 minus u2. So we applying this formula, we get this term u1 plus v1 equal v2 plus u2. Transpose u2 here and v1 here. We get u1 minus u2 equal v2 minus v1. This is called velocity of approach. Okay, velocity of approach, and this is called velocity of separation. Hence velocity of approach is equal to velocity of separation. It is asked in examination, prove that in one dimensional elastic collision velocity of approach is equal to velocity of separation. And in next video we will calculate the velocity v1 and v2, means velocities of the two body after collision. For that we will apply this equation as well as equation number 1. Thank you.